However, I think this one is better than this one, particularly for fixed pitch air propeller driven airplanes. Because for it, you only have to assume what Oswald's efficiency factor is. Again, you know, you throw in 0.8, say that's what it is. Of course, nobody really knows. Okay. So, I use this one because I think it makes more sense. PIW, again, you know, we can solve that equation we did last time. Brake horsepower times the square root of density ratio, okay, divided by the weight ratio to the 3 halves. We looked at that when we talked about level flight performance, right? CIW, same sort of thing. Before you get this temperature corrected rate of climb though, you have to do this. Here's the temperature corrected rate of climb. You take your observed rate of climb off of this plot, okay, and put the ambient temperature for that altitude over the standard temperature, okay. That's what they call the tape line rate of climb. It's as if you actually had a tape measure and you measured what that climb change was, okay. So that's the tape line rate of climb. You put it into the CIW equation. Again, multiply it times the square root of the density ratio and divide, in this case, the weight ratio by the square root of the weight ratio. Okay, so those are the 2 plots, or the 2 values that you get for each altitude. Then you plot those 2 altitudes up, and you get a plot of PIW versus CIW, which will look, you know, we're going to end up getting 2 points, you know, because we did 2 altitudes. You know, and we're going to draw a line through that, and then, okay, to determine what our rate of climb is at sea level, we're going to determine what the engine horsepower is at sea level. And we're going to go in here, get that curve, go down and read the sea level rate of climb. And so this value will be the sea level rate of climb. Now, if we want to take that altitude, we're going to have to work our equations in reverse, okay? The PIW-CIW method is the only one method you have to do that to. That's one of the advantages of the other 2 methods, is you don't have to do this expansion to altitude, because this curve only gives you the sea level value. So then you have to work it in reverse to get the rate of climb at altitude. But I still like it better. I still think it's more reasonable than the others. Here's the equivalent altitude. I show you it, and notice the only assumption you make on it is here, this guy. You end up getting an induced drag correction. That's what this is, okay, and you plug that, you get the weight corrected rate of climb, and you plug that in. This method works pretty well. It isn't as sensitive to temperature inversions. I tell you, all climb data is sensitive to temperature inversions, but the density altitude method is the worst for temperature inversions. You really, in order for density altitude to work well, you need a pretty much standard lapse rate. PIW, CIW will handle non-standard lapse rates. This one will handle non-standard lapse rates fairly well. but density altitude will not. And I've had students do thesis comparing these methods, okay, and was essentially the finding. So we're going to use PIW, CIW for the lab in this course. And there's some other methods we won't be using. There's some dimensionless methods that are used, particularly jet airplanes, can use these kinds of methods. They deal with thrust horsepower. We won't spend a lot of time on these. I just want to introduce you to them. This one you can use for prop, this one for turbojet. We've got thrust in here, thrust over delta, which is we call referred thrust. Okay. Mach number, W over delta. We've talked about that for level flight performance. And they end up with plots looking something like this. Again, here's rate of climb divided by square root of the temperature ratio, thrust, okay, here, or engine speed, referred engine speed. Again, here we've got referred thrust or referred engine speed, RPM, versus rate of climb. And from that we can get values of W over delta, weight over pressure. Like I said, only the PIW, CIW versus requires expanding to non-standard conditions. So if you want to build a climb chart, you have to take and work the equations essentially in reverse. And you can put you can say we'll do it for a standard day, and then we can put a plot of density altitude next to it, density altitude plot, and use that to get things for non-standard days. All right, questions?